Hi students. I believe that you all have understood my previous class topics. I hope you are all safe back at home. Now let's start with our next topic, non-contact force. As we studied earlier, what is contact force? Contact force means the forces are exerted by one object on another when they are in contact with each other. Okay, I repeat. Contact force is the forces are exerted by one object on another when they are in contact with each other. So what is non-contact force? Yes, the forces exerted by one object on another without any contact with each other. Okay, without any contact with each other. Okay. Next, we will move on to the next topic, non-contact force. As we studied earlier, what is contact force, and these are the examples of contact forces. Okay, so the next topic, non-contact force. The first one is magnetic force. You have learned in class 6 that like poles of two magnets repel each other and unlike poles attract each other. As we studied earlier, okay. Attraction or repulsion between objects can also be seen as another form of pull or push. Listen to that point. Attraction or repulsion between objects can also be seen as another form of pull or push. Okay. Do you have to bring magnets in contact for observing the force between them? A magnet can exert a force on another magnet without being in contact with it. Note that point, okay? A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example of non-contact force. Okay, so look at the figure. Two bar magnets. Okay, the north pole and two poles. The magnet have two poles, north pole and south pole. Listen to that figure. North pole of one magnet attracted towards the south pole of other magnet. Okay. Look at the second figure. South pole of first magnet is attracted towards the north pole of second magnet. So the force is attraction. It is a force. Okay. So the third figure C. Look at the figure C. The north pole of first magnet is a repel with the north pole of second magnet. Similarly, in the fourth figure, south pole of first magnet repels with the south pole of second magnet. So these are attractive and repulsive forces. Okay, I repeat. In the first figure, the north pole of first magnet attracted towards the south pole of second magnet. In the second figure, south pole of first magnet is attracted towards the north pole of second magnet. Okay. And the third figure, north pole of first magnet is a repulse north pole of second magnet. Similarly, the south pole of first magnet repulse south pole of second magnet. That's all. So the magnetic force is a non-contact force. Here there is no contact between the two magnets. Okay. Yes, look at the points. Magnetic force is a force exerted by magnets. So we discussed earlier. Okay, example, force of attraction and repulsion between two magnets. The force exerted by a magnet on a piece of iron or steel. The force exerted by a magnet on a piece of iron or steel. Steel is a magnetic material. It has magnetic property. Okay, it is attracted towards the magnet. Okay, look at the figure 1. The steel is attracted towards the magnet. We hope it is clear. So move on to the next topic, that is electrostatic force. Okay, listen to the next topic, electrostatic force. Listen to the points. Okay. Many of us have the experience of seeing a spark or hearing a crackle when we take off our synthetic shirts or nylon sweaters, particularly in dry weather. Sometimes we feel the sensation of an electric shock while opening the door of our car, or by holding the iron bar of a bus after sliding from our seat. The reason for these experiences is discharge of electric charges through our body, which were accumulated due to rubbing. Underline the word rubbing. Okay, I repeat. The reason for these experiences is discharge of electric charges through our body, which were accumulated due to rubbing of insulating surfaces. Another common example of electric discharge is the lightning that we see in the sky during thunderstorms. We know that when a glass rod is rubbed with a piece of silk, underline that statement. When a glass rod is rubbed with a piece of silk, the rod acquires the property of attracting light objects like bits of paper. Okay, I repeat, the glass rod acquire the property of attracting light objects like bits of paper, straw, pit balls, dry leaves, or even dust particles towards it. Okay, the glass rod is said to be electrified or charged. Note the point, when a glass rod is rubbed with a piece of silk, the glass rod acquires the property of attracting light objects like dust particles, dry leaves, paper, etc. Okay, the glass rod is said to be electrified or charged, which means there is a process of rubbing happening. Okay, after the rubbing, there is the glass rod is electrified, means charged. Similarly, for another example, a plastic comb. It is a everyday example. Okay, that is, a plastic comb gets electrified on passing through dry hair. A plastic comb gets electrified on passing through dry hair means a plastic comb is rubbed against or rubbed with the dry hair. The plastic comb gets electrified. Okay, these are two examples. First one is a glass rod is rubbed with the silk. The glass rod has the property of attracting light objects, which means it is electrified. The second example, a plastic comb is rubbed with the dry hair. The plastic comb gets electrified. Okay, clear? The metallic bodies of cars and trucks also gets charged because of friction between them and the air rushing past them. This charge, being large, can produce even a spark. Okay, note the point. Such a spark can be dangerous in case of petrol tankers. That's why petrol tankers often have a metal chain dragging along the ground. Underline that statement. In case of petrol tanker, that's why petrol tankers often have a metal chain dragging along the ground. The charge produced leaks to the ground through this chain. Okay. Nowadays, the tires of cars and trucks are made by adding some carbon compound to the rubber. This facilitates the charge built up on the body of the vehicle to leak to the ground. Okay. These are important points. Okay, so we get the conclusion. Electric charges are produced due to friction between two insulating bodies which are rubbed against each other. Okay, electric charges are produced due to friction between two insulating bodies which are rubbed against each other. The charges on insulating bodies cannot move thereon. That's why it is called static charges. So in this case charges are at rest. Okay, the two examples we have discussed earlier. The two examples. First one is a plastic comb is rubbed with the dry hair. It is electrified. Is rubbing means there is a friction takes place in between two bodies. In the first case, glass rod gets rubbed with a piece of silk. The glass rod gets electrified. Means rubbing means there is a friction takes place. Okay, so underline these, note the points. Electric charges are produced due to friction between two insulating bodies which are rubbed against each other. Okay, clear? That is that the electric charge means something possessed by material objects that makes it possible for them to exert electrical force and response to electrical force. Okay, electric charge is something possessed by material objects that makes it possible for them to exert electrical force and to respond to electrical force. Okay, clear? So look at the figure. What is electrostatic force? Electrostatic force is a force exerted by a charged body on another charged or uncharged body. The force exerted by a charged body, we know that charged body. So we have discussed earlier. That is electrostatic force is a force exerted by a charged body on another charged or uncharged body. Okay. Example, a plastic straw. Look at the figure. A plastic straw charged by rubbing with paper attract a suspended plastic straw. Then a plastic straw charged by rubbing with paper repels a suspended plastic charged by rubbing with paper. Okay. So electrostatic force So we are moving on to the next slide. Gravitational force. It is a non-contact force. Listen, you know that a coin or a pen falls to the ground when it slips off your hand. Leaves and fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? When the coin is held in your hand, it is at rest. As soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Underline the word, underline the statement. Okay. It is clear that the state of motion of the coin undergoes a change. Can this happen without a force acting on it? Which is this force? Objects or things fall towards the earth because it pulls them. This force is called the force of gravity. So underline, objects or things fall towards the earth because it pulls them. Pulling force. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all objects. The force of gravity acts on all the time without or being aware of it. Water begins to flow towards the ground as soon as we open a tap. Water in reverse flows downward due to the force of gravity. So, the point, it is a force exerted by the earth on all objects. It pulls all objects towards earth. Example, water in river flow downwards. Leaves and fruits fall to the ground when they get detached from the plant. A ball thrown upward falls down. A coin or pen falls down when it slips off your hand. So these are examples of gravitational force. I hope it is clear. I repeat, there are three non-contact forces. First one is magnetic force, and second one is electrostatic force, and third one is gravitational force. In contact forces, there are two contact forces, muscular force and force of friction. Okay, I hope it is clear. So we are move on to the next topic, pressure. You have learned in class 7 that strong winds during a storm or a cyclone can blow away even the rooftops. You also learned that winds and cyclones are caused by the differences in air pressure. Is there any relation between pressure and force? For example, try to push a nail into a wooden plank by its head. Did you succeed? Try now to push the nail by the pointed end. Could you do it this time? Try cutting vegetables with a blunt knife and then with a sharp knife. I repeat, try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? Do you get the feeling that the area over which the force is applied? For example, the pointed end of the nail. Okay, I repeat, do you get the feeling that the area over which the force is applied plays a role in making these tasks easier? So, the force acting per unit area of surface is called pressure. So, the force acting on unit area of a surface is called pressure. That is, pressure is the force per unit area. Okay. So in these two processes, I repeat, the first process, try to push a nail into a wooden plank by its head. Did you succeed? No. Try now to push the nail by the pointed end. Could you do it this time? For another example, Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? That is, we get the area over which the force is applied plays a role in making this task. That is, the pressure is the force per unit area. Pressure is the force per unit area. At this stage, we consider only those forces which act perpendicular to the surface on which the pressure is to be computed. So look at the figure examples. It is easier to push a nail into a wooden plank by its pointed end than its head because the pressure is more. Okay, it is easier to push a nail into a wooden plank by its pointed end than its head because the pressure is more. Because the pointed end, the area is small, the pressure is greater. Okay, area is small, pressure is greater. Without that, pressure is equal to force per unit area. If the area is smaller, the pressure is more on the pressure is more. If area is smaller, the pressure is more. I hope it is clear. We move on to the next example. It is easier to cut vegetables with a sharp knife than a blunt knife because the pressure is more. The same reason, in the sharp knife, the pointed end means the sharp end, that is, the area is lesser, the pressure is more. Okay, the pressure is more. Okay. So the next example, shoulder bags have broad and not thin straps to reduce pressure because the shoulder bags have broad straps, the area is larger, the pressure is less. The pressure is less means a less force is applied. Okay, I hope it is clear. We move on to the first examples. There are two cases. Listen. A lady wearing sneakers on Monday. You are sitting on a bench of reading newspapers. She starts jogging and accidentally puts her steps on your foot. I repeat, case A. A lady is wearing sneakers on Monday. You are sitting on a bench reading newspapers. She starts jogging and accidentally puts her steps on your foot. The case B. Same lady wearing heels on Tuesday. You are sitting on a bench waiting for a friend. She was walking. In order to take rest, she moves towards the bench and accidentally steps on your foot. I repeat, same lady is wearing heels on Tuesday. You are sitting on a bench waiting for a friend. She was walking. In order to take rest, she moves towards the bench and accidentally steps on your foot. The question is, in which case the pain is more? So, let's discuss the questions. What is same in both cases? The force is applied is same. But in first case, a force is applied on bigger area. Force is applied on bigger area. And second case, force is applied on small area, which is a heeled sandal. Okay. The first case, lady is wearing sneakers, which means in case A, force is applied on a bigger area. In case B, force is applied on a small area. But The same force produces less pressure if it is acts on a large area, but can produce more pressure if it is acts on a small area. Note the point. This is the answer. This is the answer. Okay. The same force produces less pressure if it acts on a large area, but can produce more pressure if it is acts on a small area. In the first case, lady wearing sneakers. So the force is applied on a bigger area. So force is less or pressure is less. The same force is produces less pressure if it is a larger area. So if lady wears sneakers, that is larger area, that is less pressure. Note that points. If lady wears sneakers, larger area, less pressure, and but can produce more pressure if it exerts on a small area. That is lady wearing heels. That is the answer. Thank you.